he said, you're going to do it on FPGAs because we need the throughput. And I said, I don't know what FPGA is. So it's okay. You'll figure it out.
You figure it out.
Right.
Wow. So, all right. So now the story's even better. Pizza delivery man to nuclear physicists running one of the top HPC clusters in the nation. That's a really cool story.
You know, life just kind of goes the way it's going to go, and it's kind of fun to see what happens, right?
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
On today's episode, Revolutionizing HPC Management, with special guest Aaron Jezghani, pizza delivery man turned nuclear physicist, now managing HPC clusters at Georgia Tech. Aaron, welcome to the show.
Hey, Darren, thanks for having me today.
Hey, we had some fun talking about what you're doing at Georgia Tech, and just some crazy things that are going on there. And I said, wait, we got to capture this on the podcast. So I abruptly said, Aaron, stop, because I want to be just as surprised as my audience when I hear what great things you guys are doing there. But before we talk about that, and where that has come from and how COVID played a part in it. I think that's a fascinating part. Let's hear the backstory of Aaron, the superhero Aaron. Every superhero has a backstory. Where's your backstory start?
Well, that's a lengthy one. So I joined Georgia Tech in 2019 after I finished up my PhD. I was actually an experimental nuclear physicist in a past life.
Wait, you have a PhD in nuclear physics?
Yes. I did my dissertation work out in Los Alamos and Oak Ridge National Labs.
Okay, now I've had everyone on the show now.
And so for my dissertation work, I designed our data acquisition system. So I was writing FPGA firmware. And then being that close to the origin of the data, got into GPU, CPU for simulation and some analysis efforts. Did some custom DSP work to try and, get the maximum signal to noise for the experiment, which gave me just kind of those low-level coding skills, right? That then the opportunity opened up with PACE, which is our central research computing group here at Georgia Tech. And I came on as a facilitator initially, never having touched a cluster before in my life, but basically just there as a consultant, help people figure out how to submit jobs or why things were broken. And then it kind of very quickly evolved because I got annoyed that the scheduler kept crashing. And so physicist Aaron said, hey, what if we fix that? And they're like, wait, we don't really mess with that too much because it can break everything. I said, no, I think we can do it. And so then that led to me being the scheduler architect. And then as, our policies evolved, it just kind of kept running amok from there.
Wait, I got to go back a little bit because you said you have a PhD in nuclear physics, and now you're a sysadmin type of guy, right? I mean, you're managing these big, huge clusters. Do you miss the physics part at all?
So actually, I'm still involved in a few collaborations and contributing. In fact,
so you're still doing it.
Yeah. No, we have a whole data pipeline from Oak Ridge down here to Georgia Tech. We do analysis, simulation. We're very effective at scavenging cycles. So I had a guy that was consuming 100,000 CPU hours over the span of a day or so, just by picking up what was left behind. And we come up with creative ways to tackle our needs as an experimentalist, and it provides good insights for how to serve the community. Because as a researcher myself, I can think of the things that I experience and what types of problems I want to solve.
Okay, so this is really cool because you've taken your love for physics. Obviously, if you have a PhD in something, you've got to have a passion around it, and you picked up this side stuff to help you do better with what your real passion is which is nuclear physics. That's what it sounds like. Is that?
Well, So actually, it
Or
was
has your
kind of
passion changed? Has your
I
passion changed to high performance computing?
no, I mean I think I like solving problems. Is what all right.
Okay.
So I mean actually the road to even getting my PhD was kind of a wild one because my first bachelor's degree, I have two bachelor's degrees. My first one, I did not do so well, right? You know, time and place in life.
Yeah.
Actually, the whole reason why I was able to get that degree was because I took a second semester of C++, and that brought my GPA up enough to carry it forward. So I went up to Buffalo, New York for a while and was working at a pizzeria, and then decided, you know what, I want to go back to school, and decided to try physics secondary education, actually teach high school, right? But then my advisor was like, Aaron, like, no, go for your PhD, come do some research so you can see what it's like. And I was like, okay, actually, this is fun. I dig it. I started off actually because he was a solid state. We did single crystal growth.
Oh,
Uh,
wow.
and so I was thinking like, oh yeah, you know, so in a very different sense, the computing, right? I'd be building out like the actual semiconductors for building out chips. And instead, I got to Kentucky where I did my PhD and was like, you know what, actually, nuclear physics sounds fun. And my advisor was like, okay, I need someone to build a DAC. I was like, I don't know what that means. He's like, all right, well, it's okay. You take data from the detector and do stuff. And I was like, okay. And then he said, you're going to do it on FPGAs because we need the throughput. And I said, I don't know what FPGA is. So it's okay. You'll figure it out.
You figure it out.
Right.
Wow. So, all right. So now the story's even better. Pizza delivery man to nuclear physicists running one of the top HPC clusters in the nation. That's a really cool story.
You know, life just kind of goes the way it's going to go. And it's kind of fun to see what happens, right?
So let's take your life, because your life really kind of shows what happened with what's going on with PACE, because it's been around a long time. And what does PACE stand for again?
So it started off as a different acronym, but today it's the Partnership for an Advanced Computing Environment.
Okay.
Right. And so, you know, at its inception, it was what a lot of universities do, where it was a condominium based model. Faculty get grants or they have their startup packages. They buy the compute servers and then a central entity hosts it, and maybe, you know, makes it so that they've got priority on their system, but then they have reduced priority on the other systems to allow them to do a bit more. And it kind of grew from there, right? So this is back in like 2009 was its origin. And so I came in 10 years after it had already been up and running, and it was already a beast.
Oh, I bet. Yeah, and there's process around it. There's hardware. And I imagine after running for 10 years, they had a lot of different kind of hardware
Yep.
running
We had
in there.
like 60,000 cores at the time, spanning, I think there were 12 or 14 different CPU SKUs that were as old as, you know, 10 years old, you know, so basically from the beginning of time. You know, GPU. Well, I mean, right in the terms.
Yeah,
of
you're right.
cluster,
10 years, 10 years in CPU realm is the beginning of time. Yeah.
you know, and so I came in and I was definitely thoroughly impressed, right? Because like the amount of service and just the capacity was something that as a grad student, I was like, wow, this is amazing. I would have loved to have access to this. But you know, I was able to see pretty quickly the challenges that presents, right? In terms
So
of
what were some of the challenges at the beginning that you saw?
right.
Because I
So
mean, things kind of grew organically, right? I mean, they had process around it, but you just kept buying more machines on top of what was already there, because that's what organizations do.
right. Well, and especially in an academic setting, right? Different researchers have very different needs, and so they sit there and they buy what makes sense at the time. And you know, I mean, right? Anyone that's in an academic setting knows that you buy the hardware and it's going to last you your entire tenure. But
Because you only get to ask for that hardware once, is what you're
right,
saying.
exactly. But what we ended up with, well, so they did do a couple refreshes to at least phase out some of the older hardware, but then they had some that had held out and, you know, not had the opportunity for that, perhaps, or the faculty had gone, so it wasn't necessarily part of it. But effectively, the heterogeneity ended up being one of the biggest challenges because the InfiniBand that we were running, we had like 3 or 4 generations of that. So it fragmented the cluster in a lot of ways. We had some file servers that were completely isolated from the rest of the cluster, the compute architectures with a different level of policy. And in fact, one of the biggest challenges was the scheduler itself, because we were operating under this condominium model where each group that bought their hardware had a priority queue.
Had priority queues,
So we
yeah.
had, when I joined, like 114 different queues on the cluster.
Oh, and
And that is,
managing that.
yeah,
That's
that's a big part of why it just kept crashing, right? Was that it was a lot for it to handle.
it wasn't
Um,
designed for that. Yeah.
exactly. And so then one of the big changes that happened was right as I moved in, they had a new data center open up. Right. And so this was something that had been in the works for several years that basically it's this whole tech square revitalization. So if you're ever in Midtown, you can see all this new construction ongoing. And it was twofold, that they had an office tower that was a multi-tenant facility that would marry the academic side with the faculty and the students, with the researchers coming out of GTRI or the other units, and then industry, right? So we have several different companies that are tenants in the building, including Cisco just moved in up at the top,
Oh,
um,
wow.
with this collaborative core in the middle, where all the tenants had access to a shared space that they could go sit and just engage sporadically and spawn wonderful things, right? Similarly, the data center, is a colo facility that sprung up, and Georgia Tech, is the anchor tenant, but then other entities are able to occupy the other floors. And again, it's to bring together kind of the best of both worlds and provide that.
Right.
Um, but being a colo facility and trying to be strategic, in terms of how we operate, realized that it was more economical just to buy new hardware and reduce our footprint, to reduce kind of that lease inside the data center.
Okay, so we got to talk a little bit about that because
Yeah.
um 10-year-old hardware compared to, so you were basically throwing out 10 years of hardware to buy new hardware, because it was more cost effective both for power and floor space,
Yep.
and just having that homogeneity, you're saying plays a big role in OpEx costs.
Yeah, no, absolutely. I mean, the administrative overhead to have to support, that many different generations and builds, and, some of them couldn't support newer operating systems. So being able to move forward and keep things consistent. We did, work out a deal that there was a buyback of a lot of the old hardware so that, was
Okay.
able to sit there and offset the cost of the new hardware as well.
Well, and,
Um,
and those probably got resold to other organizations that could
exactly,
take
exactly.
advantage of
Yeah.
it. Right?
Yeah, I
So
know.
we didn't throw them in the dumpster
Mm-mm.
behind the building,
Nope, nope.
which
They
is that's
had a
good
second
to hear,
life.
right?
Yeah,
Yeah.
and what's interesting is we the way we went about it was we looked at just a standard benchmark to figure out like computational capacity. So not necessarily the same number of cores, but you're remaining parity in terms of what the throughput could be in terms of computation, and use
Okay.
that to level set. And there's a whole methodology that we've published and presented at PERC that kind of discusses this, but basically we didn't increase the number of flops that our system could do. But what we did do by unifying to a single CPU SKU and unifying under a single, network topology, was allow us to then actually finally get back on the top 500 right after that happened, right? Because
Fascinating. So you didn't change the total capabilities,
exactly.
but you got better throughput because of the homogeneity. Probably the scheduler could do a better job at scheduling. I mean, there's a whole bunch of things that simplifying the infrastructure made a big difference.
Absolutely. And so just looking at it in terms of what that refresh was able to do for us, in terms of keeping things, more operationally sound and being able to actually highlight what it was capable of doing. The other part of it, though, was as you mentioned, right? This all happened in the heart of COVID, and so when you're trying to order thousands of nodes and the whole world was shutting down, the substrates for the chips were going to produce like the vials for the vaccines instead, and all these types of things. we started hitting hardware delays, and we had already been encountering some issues with procurement and the time cycle there that was
Right.
delaying access to the systems for new startups, for faculty, or if they get a new grant and they want to grow their capacity, right? Um, and so all of this together, and realizing that we were on pace for this, we said, you know what if we actually pivot from that condominium model into a consumption-based model, right? Like an on-prem cloud, if you will.
Oh, so much more a modern, right? Centralized, central control, easier to manage. How did the faculty take that? Because you were
It
taking
was
away. Are they server huggers? Because I'm a faculty member now at
right.
Vanderbilt, and I could see server huggers because if I got a grant for servers, those are my servers, right?
Well, right. So there was it was a bit of a funny situation, right? And I mean, in hindsight, we can look at it and say, okay. So basically, as the guy doing all the scheduler work, they said, hey, we got this new accounting software. Let's see if this is even a viable concept, and let's push it out to next year, right? And I took a stab at it and had a POC a couple days later, and they're like, oh, okay, that was actually a lot easier than we thought. Let's go ahead and do this. But the problem was that then we had to settle, like, how do you determine what the rates look like? How do you make it compelling? And so, when we calculate the full rates, we say, okay, this is the total encumbered cost. That includes not only the bare metal hardware purchase, but all of the
But
OpEx
also
that
the OpEx cost, yeah.
exactly. Um, but then we end up subsidizing it internally to the faculty back to what that bare metal costs, because as faculty, you can buy a server, you're not going to pay all that overhead. I mean, right? It's just baked
No,
into
you're
it.
not.
If you have a grant, there's not that FNA that gets tacked on. So we also had to be exempt from the FNA, and that was a whole process. And so, getting all of that through and approved and all that basically gave very little heads up to anybody that this was happening. And so, as we're trying to move them in, we're like, oh, by the way, we restructured things, but here's how this is going to pan out for you. And there were the immediate selling points of, you have, instead of having like a fixed lifetime on your hardware, right, where there's ebbs and flows to research and
Right,
it may sit
right,
idle, those are lost cycles, right?
right.
But in the world of having credits, uh, you've got credits, they don't expire, in that same way. And so you can also scale up, right? You're not restricted to the same amount of hardware you had originally purchased. If you need more, you go bigger.
So this is really interesting because one of the key tenets that we talk about on the show is the people aspect of
Right.
adopting new technologies. And you guys came up with a strategy that you made it easier, more cost effective, and you kind of put the hammer down on them at the same time, which was really kind of interesting, right? Because you said this is what it is, and you made it easier at the same time. So you probably didn't get as much resistance as you normally would, and COVID was happening at the same time. So you picked a perfect time to do all this.
Right. No, and what I'll say is, I mean, certainly part of the approval chain was going up through senior leadership at the institution, so that way they would vouch for what we're saying, right? But then also
which
had
is
to be
important, right? Yeah.
the assurances that they were going to get the quality of service that they were looking for, and then being able to show that it was doing what we said it was doing, right? That was the other key part of it, was that, yeah, there was definitely some groups initially, were very, very upset. I would say that there's probably still maybe a few people that aren't as excited, but the numbers are there to highlight, right, that when you compare to the old model, we went from like 35% cluster utilization to exceeding 85% today.
35? That's all you were
Because,
getting?
well, because when you
Oh,
fragment
because it was
resource,
fragmented. Yeah,
yep,
yeah.
and especially if you have faculty that left, their hardware, doesn't get
Just
exactly.
sitting there.
The other part of it is that, as people have modified their workflows. So, for example, we have a faculty in material science and engineering. Historically, was doing like a lot of the ab initio calculations on CPU, so that's what he had invested in. But moving into this new model, he was able to shift to graph neural networks and being able to do things using the GPUs, because again, the credits can commute across the
Yeah,
different
they
types of
can do it.
resources. As
So,
we,
so
yeah,
yeah, that's a really good selling option. Is you have more compute power than you would normally, and different options.
Yep.
Maybe even FPGAs, since you're an FPGA guy. Maybe we could even put FPGAs into your cluster, right? So people could do FPGA type scheduling if we could get a scheduler to do that. I don't know.
Well,
Can we
so
get a scheduler to do
it's
that?
funny you mentioned that, because actually we have a novel architecture test bed here on campus that I also help out with.
Mhm.
That includes a variety of FPGAs, and in fact,
Very
um,
cool.
we have it's like 60 pink Z2 boards, and we've just added a bunch of Ultra 96 to get the 64-bit ARM coprocessor as well, that are all under Slurm with Open on Demand. And so our systems architecture class and some of the ECE FPGA coursework use that. And the whole reason for that was actually a capacity issue. That as the College of Computing changed the number of students that needed access to those systems and they're required to take the class, we realized that the bookstore couldn't populate enough of those boards to meet the need. And so instead of
Yeah,
offloading the
there you
cost
go.
to the students, we host it centrally. We make it available. It's a cloud of development boards with FPGAs, and they just go through their browser and they land in a Jupyter notebook exactly like they would if they have the hardware in front of them
Wow.
to do what they want, right? And so yeah, we
Well,
have everything, right?
yeah. Do you still have some faculty members in some departments that still want to physically touch devices?
So it's not so much necessarily that they want to physically touch the devices, but maybe that they want them to be theirs and ensure that.
Yeah,
And we've
yeah,
actually
that's what I
figured out
mean.
that there are certain funding options where this is a grant that only
Yeah.
buys hardware, right? So
No, of
NIH
course.
or
Yeah, you do
DARPA,
run into
I've
that.
seen a couple of these awards. And so the thing is actually we're able to blend it into our existing model by basically only offering up opportunistic cycles when they're not using the box to the community, right?
Okay, so you've gone to centralized private cloud. Basically, you have a private cloud for HPC,
Basically.
basically. Or but you also have allowed um, you've allowed for in bare metal provisioning of machines, so I can have a dedicated machine, and then when it's not being used, I can harvest cycles off of it. Is
Right.
that
Now, I mean, I'll say that generally speaking, the preference is not to go that route. Like that's there, it's more
right? Right,
conditional.
but you're going to have
But
some special cases, right, where that's
right.
the case.
But I mean, certainly the other things that are nice is that as we do onboard new faculty, it's a lot easier to facilitate the credits going into PACE than having to have, special boxes that are being housed and managed by other units across campus. And the capacity and the scale. I mean, that was the other outcome from this move, was that suddenly, because there was more resource, the groups that were heavily using scaled up to 40% increases, 50% increases. I look at aerospace especially, right? Some of those big CFD code that they run that are entirely CPU, before they were limited to 1,000 cores, something like that, they hit 6,000 cores and run like many day jobs. And it's not a problem because it's just this big cluster
Because
that
you
can.
have enough capacity to
Exactly.
handle.
So it's
Yeah.
allowed a whole new world of research capability because of that. And we've done some other things to restore the trust, right? We established like an advisory committee that's joint with the faculty and the EVPR's office to discuss as these changes are happening. Trying to be more in partnership with the academic units, so that way we're not operating in a bubble outside of what they're looking for, but
Oh, of
actually
course. Yeah.
partnering with them every step of the way.
Well, because if you do, then you start diverging
Right.
from what they really need, and then they're going to go somewhere else and find it, or they'll start creating shadow IT. They'll start. I've sold a couple mini clusters under people's desks, and not at Georgia Tech, but at other organizations.
Yeah, we have an infamous cluster here called Skynet. That's a fun one because it's actually, as you would imagine, right? It's one of the early ML systems that was spun up with a bunch of like
Uh-huh.
8-way GPUs. It's run almost entirely by PhD students, and at this point, it's like 90 servers.
Yeah, nothing can go wrong with that.
Well, actually, I'm impressed, to be honest. I mean, they stood up Slurm. They've got a whole set of Ansible playbooks to manage it. They set the policy. What I found is actually they're more aggressive on policy than we are,
You guys know.
because they have that vested interest that that's their resource. And if someone's doing something that breaks things, it impacts them in a big way, and so they
Oh
come
yeah,
down
yeah,
really
yeah.
hard. I mean, there's definitely need for kind of multiple modes of how you support IT for research computing, because like for example, there's a lot of folks that are doing cybersecurity work. They probably have some policy that you don't want
That
on a
you
big
don't
cluster
want.
like this,
Yeah,
right?
yeah, yeah, yeah.
The novel architectures and hardware, right? We want to support it, but at the same time, we want to do it in a way that's not going to be cumbersome or arduous to do so.
So that's kind of that 80/20 rule, it sounds like, where, hey, you're going to handle 80% of all the cases, maybe even 95% of all the cases, but you still have the flexibility of having the 5% where they're going to do something kind of crazy that you don't want to affect other people that are using, your private cloud. Which I think this is a great story in that, right? But as soon as that number climbs to 70% are using it and 30 aren't, then you need to start making changes, right? Because you're starting to lose some of your economics benefits when people don't want to use it. So I love how you guys have created the council or the advisory council to stay close to who you are serving and making that a priority. I think that's brilliant.
Yeah, no, it's definitely been very effective. And I mean, we made sure that the composition is reflective of a wide range, right? Like
Yeah, you
it's
have to
it's
you have to go wide. Yeah.
right. It's very easy to say, okay, these are the big users, but there's a lot of they talk about it as the long tail of science in the NSF, right? That there's a whole swath of people that are coming from social sciences or music and arts are starting to see kind of
Really, music and arts.
yeah, actually. So we maintain an instructional cluster that is basically an HPC cluster dedicated exclusively to instructional use. And I know we hosted a computational musicology course a couple years ago on it,
That's awesome.
right?
That is awesome.
Our College of Business is one of the big growing groups on campus that's starting to tap into it. And I think a lot of this stems too from just AI and what it's done for accelerating the access to compute, right? Because that's always one of the biggest impediments to getting people onto the system and being able to use it effectively is how do you
How easy.
exactly, right?
Yeah.
When I first joined, we were very much in the you write a batch script and you submit that and leave it at that. And then basically said, okay, you know what, like let's see where we can go with this. And so we rolled out Open on Demand shortly thereafter. That was actually kind of a funny one because we started on that novel test bed on the A64FX because they said, okay, can we spin up tutorials and make them available through a
Make
browser
yeah,
for
yeah, that makes sense.
right? And so that was actually presented like the Iowa HPC, the International Workshop in ARM HPC and Experience, and it led to Riken actually saying like, hey, that was really cool that you had this open on demand thing. How do we get that on Fugaku? And I said, oh, that's outside of our knowledge because like you have a special scheduler that you use, but you can talk to the OSC folks. And so they've done that, and they've presented multiple times at like the various like at OSC's booth and given talks about the experience and the opportunity. Because if you make it accessible, people are going to take advantage, right?
To take advantage of it. I think you hit it right on the nose. If you make it accessible, easy, cost effective, they know how much it's going to cost, right? And you have that whole credit system. I think what you guys have come up with is a great story of success. So, Aaron, this has been wonderful learning about this because you brought people, process, and technology all together to make something really successful, and and COVID gave you the opportunity to really do it,
I,
right? I mean, this is all cool.
yeah, no, it's been a wild ride, and I mean, what's fun is that too because of the visibility and the prominence into the operation and kind of making it more obvious what's going on there. It started spinning up a lot of the folks coming out of actually like aerospace engineering. We're building out a digital twin of the data center to look at how do you improve operations, how do taking advantage of all like the generative AI to simulate and enhance how we do
Right.
things. We've got folks from GTRI that are looking at infrastructure resiliency and can you do co-scheduling with the power grid and marry that to your data center better,
Very cool stuff. Yeah.
right? ECE, ISYE, and CSE, right, are all looking at sustainability of operations, carbon footprint, and how do you design policy and systems to be more effective and more sustainable environment. You've talked about sustainability from the context of, the finance of it, right? Being a public institution, that's always how do you get the stuff there.
Yeah.
But there are, there's the sustainability in terms of the environmental impact as well. And so, the nice thing is that we say, yeah, let's work together. Here's the data, right? We can provide all that data, and so you don't have to operate under a toy model of this is how a cluster works or simulate it. You can look at actual utilization. You can see actual workflows. Yeah. And see, okay, where do we stand on the network? Could we optimize distribution of resources or change the cooling, or it's a fun one to help facilitate and look at, because I don't think that there's many places that's available at that level for users.
No, I think you're right. So Aaron, this has been wonderful. Thanks for coming on the show. We're going to talk again because we got more to talk about. So look forward. If you're listening, look forward to seeing Aaron come on again in follow-up episodes.
Thank you so much, Darren. It was a pleasure to be here.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.